Okay, so we're back. Let's go to example 2A in our notes here, okay? Last time what we did was, and I need to be quicker on my sharing thing. Oh, here it is. So last time what we did was we created the second step, right? And this was an exponential, let's double click, exponential 25 minutes and capacity of 2, okay? So now instead of having one process that have 2 resources, one step that have 2 resources, I'm gonna actually have 2 steps that are happening at the same time, each one with 1 resource, okay? So just create it like this. I'm gonna drag it down so it's exactly like the example. And then here, I'm going to be process. I'm going to do exactly like the example so you guys are not lost. Process 2A, and this will be process 2B. And now, but here, the capacity for 2A will be 1, and the capacity of 2B is 1, and the exponential of the time of 2B will be 125. So before I had one step saying that there's 2 unit, the capacity was 2 for that process, and you could do exponential 25. Now I'm breaking down, I'm putting them separately, but it's the same resource. So imagine that I have, instead of having 2 equipment that were one inside the other, now they're in different parts of the plant, or just I'm detaching those 2, right? And now we're actually looking at something being divided in 2, right? So we have 2 pathways here. So if you click on the routing, it will tell you, what type of routing do we want, and this is called a percentage one, and that's the automatic version of it. It will say 50% each side, right? So you can change here, you can put 25, you can put 10, and it will calculate automatically for you, okay? So now we're saying that we have 2, but it's the same resource, right? So the question is, what is that going to change in the results? So the results that we had before was about 37 minutes of value-added time. Remember that because it's 12 plus 25. And we had about 100 minutes of waiting time, right, to the whole steps. But our resources were together. Now we're separating them and saying, okay, 50% goes one way, 50% goes the other way. So it's going to do one way, the other way, one way, the other way, one way, the other way, right? Instead of coming and having 2 resources to take them, right? So what do you guys expect to happen with the waiting time? Is that going to be the same? Is that going to increase? Or is that going to decrease? Okay, put your bets. What are you going to bet on? Choose one. Okay, and let's simulate. So, I not change the resources. I still have the same amount of resources, right? So I still have 2 equipment to stay at the same time. So you might think, well, that's not going to change them. It's the same resources, right? But let's see how it works. The only thing we changed was actually the method, right? Instead of going always one way and you have 2 resources that you could use, now it's dividing first and then get to the resources, okay? So let's see what's happening. Look at the cycle time. 188, 200. Value added is the same, right? Because the resource in the process is the same. But just by altering the method that I'm going to divide this queue, that I'm going to divide the route of my product, just by doing that, look at what happened. Yes, of course I want to see the results. I'm dying to see the results, right, guys? Look what happened. Utilization didn't change much. It was about this. But let's go back here, let's go down, sorry. Look at the value added time. Average cycle time jumped from 137 to 210, okay? So we jumped from 100 seconds of waiting, 100 minutes of a waiting time to 80 minutes of waiting time, 80% more of waiting and waste in my process. Why? Just because I put a rule that whenever it goes out from one process, it divides into two and then goes to each station separately instead of going to whatever station is open at that time. And by that rule, that's a method thing. It's not a resource, same equipment, same people, same skills, same product, same process. Just by changing one rule, I, did a very bad thing. And we didn't know that before doing. And that's the power of process model, that you can use these rules and change things, tweak here and there, and some things that are not logic, before become logic after, and you kind of realize a bunch of things that you're doing right or wrong before actually doing anything, right? And that's very, very could be a very powerful thing if used wisely. And I know you guys will use wisely because they're responsible people. Okay, so you can take a look here and see that 210 and 37 minutes. So that's a very bad thing, right? That's a very bad solution to our problem. Okay, does that make sense? Hope so. Okay, now we're going to example 2B, okay? So keep on the notes, 2B. So what are we gonna do in 2B? 2B, we have the same two process, but server 1 can process 42%. So let's say this one, this arrow, instead of 50%, is gonna be 42%. And it automatically changed this one to 58, right? Which is what we want, okay? Because you only have two, right? So it's just easy, quick math. What's gonna happen? So we were already on 210 minutes. Do you think that's gonna reduce the time, or are you gonna increase that waiting time? And we only tweaked a little bit and put a little bit to more one side than the other side, right? And companies sometimes do that. When they say, oh, let's have a priority lane that goes this way. Let's have, this kind of different lane. Let's only take some products in this process and other products in this process. And companies do that all the time. Let's see how it works for the average waiting time. Again, let's do another bet. Same, increase waiting time, reduce waiting time. What do you guys think? Simulate. Let's run the show. Let's make it magic happen. Okay. Oops, where am I? Here it is. Okay. So it's processing really quick, and you can see that here the number, that's the waiting line, right? The waiting line is increasing and decreasing here in both processes, going one way and the other way. And if you guys are smart enough, and I know that you are, you can see that cycle time is exploding here on top, right? And why is that? Well, it is more than 320, right? Because now you're concentrating actually more demand in one side, right? And when you have that variation in demand that happened, now this side is getting more and more. Yes, of course we need to see the results. We're dying for the results. And then one side is getting a lot more demand than the other side. So look what happened. Process 2A, which had only 42%, the utilization reduced, right? You're using less. You have less products are going that way. Now, product 2B, which was about 82 as well, now, or 84, it goes to 95% because you increase the demand on this side, right? So by doing that, you reducing one side, increasing the other side. And let's see, and you can see here already that the maximum was actually 56 in this process. So exploded up to the size of that queue, and that it impacts a lot on the average cycle time. So it went from 210 to 310 now, just by, again, a simple rule, right? And you can put a lot of different decisions into process model. This is a very, very simple, basic thing that we did, right? Just changing the rule of the path. But you can put a bunch of different rules and techniques and methods and stuff that you can tweak and change to see the impact on those things. So 310 instead of 210. So we went from 100 to 180, now 280, or a little less than that, 270 seconds of waiting time, just changing the rules, right? So a very, very bad choice. And you can see back here that this becomes basically the bottleneck of your process, right? So when you increase the utilization, it actually becomes the bottleneck, and it actually creates a lot of waiting lines here, right? Because of that. So sometimes the arrival rates are so high that the process cannot process and in a quick way. So the waiting line just increase a lot, and you cannot cope with that increase, right? At the end, you are processing everything, but because of the rule that you put, the waiting lines are kind of incredibly high. Okay, does that make sense? Wasn't that cool? Told you that would be cool. So now we're going to talk more about the resources and the path and some rules that we can use into more complex and fun process models.